Assalamualaikum warahmatullahi wabarakatuh. My name is Akil and my partner is Nofal. We are going to present about 3.3, which is evaluating by using elementary operations. Before we go any further, my full name is Akil Izzuddin bin Abdul Latif 2023486888, and my partner Muhammad Nofal bin Muhammad Naziri 2023617896. We are from Diploma Statistics from 3B, CDCS 111 3B.
Our objective is to evaluate determinant by using elementary row or column operation. Identify matrices where the determinant is 0 and find the determinant for elementary matrices. First topic, we're going to talk about 3.3.1, evaluating by using elementary row operations. By using theorem 3, the effect of the elementary row on determinant that we can follow is interchange row, which is just add negative to the matrix. Next, multiply a row with k by adding k or 1 over k to the matrix based on what we use. Then add row multiplied by k to another row, which doesn't change anything to the matrix. For the first questions, find the determinant for the following matrix by using elementary row operations. This is the question 1. The solution. First following that we can see is R1 to R2, which is just add negative to the matrix. Next operation, R2 plus negative 3 R1 to R2, which doesn't change the matrix. The next operation, R2 to R3, which just need to add negative to the matrix. And lastly, R3 plus 34 R2 to R3, which doesn't change anything to the matrix. By the result, we can see negative times negative times the index, which is 1 times 1 times 255, which answer is 255. Question 2 is the same questions. Find the determinant for the following matrix by using elementary row operations. This is the question 2. For the solution, first following that we can see is 1 over 2 R2 to R2, which just add 2 to the matrices. Next operation, R1 to R2, which is just need to add negative to the matrices. Lastly, R2 plus negative 5 R1 to R2, which doesn't change anything to matrices. What we can see, the result, negative times 2 times the index, which is 1 times negative 13, equals to 26.
Next, I'm going to explain 3.3.2, which is evaluating determinants by using elementary column operation. There are 3 elementary columns operation. First, interchange 2 columns. Second, multiply a column with a non-zero constant. And third, and lastly, add a column that has been multiplied with a non-zero constant to another column. This operation can be performed on any square matrix in order to help us to reduce the matrix and get the value of the determinants. However, it cannot be used in solving system of linear equation. Here is shown question number 3. The question berbunyi, find modulus A, B, C and D. For the solution, we use the formula AD minus BC, and we get modulus A equals to 5, modulus B negative 5, C 10, D 5. From the solution from question 3, we observe that all of these are related. What I mean is, look at the first observation. B is obtained from A by interchanging the first column and the second column in A. We found that A equals to negative B. And second observation is that C is obtained from A by multiplying the second column in A with 2. We found that A equals to 1/2 times C. And lastly, observation number 3. D is obtained from A by adding the first column with negative 2 times the second column. In A, we found that A equals to D. Before we go to the next question, we need to understand theorem 4, which is determinants and elementary column operations. First thing first, interchange. When interchange column, the new will be negative. We add the negative. When we second, multiply a column with k. When we multiply, this thing we need to understand on the question. Third, add a column which is multiply k to another column. If we add a column which is multiply k to another column, they will be even, which is equal. So below is show question number 4. Matrix. This matrix equals to 12, and the question asks find the value of matrix A, B, C, D, E, F, G, H, I. There are two ways to solve this question. First, we start with matrix on the right. This is a better way to understand. But matrix when we start matrix on the left, it's hard to understand. But both of them are equal, which is 12. We start with the solution is start with matrix A, B, C, D, F, G, H, I, row 1 to row 3. When we interchange, we get negative 1. And next, negative 3, column 1 to new column 1, 2 times column 2 to new column 2, negative 1 times column 3 to new column 3. And then when we multiply, we get negative 1/3, 1/2, negative 1, and negative 1 from before. And then we add column 1 plus column 2. We get new column 1. There are no change when we plus. And then the last answer will be we multiply with only at the front, which is negative 1/3, 1/2, negative 1, negative 1, and 12. 12 is from the question. And then we get negative 2.
Topic 3, which is 3.3.3, identify matrices which have determinant equal to 0. By looking at the theorem 5, you can understand A has 0 rows or 0 column. 2 or more rows or column in A are the same. A row or column in A is multiple or another row and column. For the question 5, we can understand the theorem 5 number 1, which in matrix A there is row 3 which is 0 row. So matrix A is determinant equal to 0. The question says we can follow the theorem 5 number 2. In matrix C, there's a same column which is column 1 and column 4. By looking at this, we can confirm that matrix C determinant equal to 0. Lastly, for the question 7, matrix B, there's no exact same row or column, but by times negative 3 with row 2, which is equal to row 1. So it's basically the same row. So the matrix B determinant equals to 0.
Next, I'm going to explain 3.3.4, which is determinants of elementary matrix. First thing first, we need to understand rule of theorem 6. First, when we do interchange, we add -1, where 2. Next, when we do multiply a row with k, we add k. Third, lastly, when we add a row and multiply by k to another row, the new will be 1. The question 8 show two questions. First, this matrix. When the question asks, we should make all of the matrix on the middle one is equal to 1 and other will be 0, and at this question -4 should be 0. When this -4, we need to change this -4 to 0, and the answer is 1 because when we add, we use the rule number 3, add a row which is multiplied by k to another row which is equal to 1. And the next question, there are -3 on inside line of 1. It should be 1, right? And then we over -3 over row 3, and then we get new row 3, which is -3, and the answer is -3 because the question is asked to change that -3 to 1. And then another question, when we interchange, it should be -1. Any interchange will be -1. That's all from 3.3.4. Huge respect to people who are watching this video to the end. Thanks for watching. Arigatou gozaimasu.